Good day, I hope everyone is doing well. At this unit, it is all about lipids. I am Mira, assigned as this experiment's host. My co-members are also with me. Dana is assigned for objectives, Mika and Karima for the pre-laboratory, and Mark and Ara for the post-laboratory. The science behind of this video will be explained by Ara, and our video editor will be Mika. This is the last episode of the Biochemistry at Home entitled Beauty and the Grease. Keep watching until the end. Lipids are one of the major constituents of foods. These are important in our diet for a number of reasons. In many foods, the lipid component plays a major role in determining the physical characteristics such as flavor, texture, mouthfeel, and appearance. Lipids are also a major source of energy and provide essential lipid nutrients. Nevertheless, overconsumption of lipid component can be detrimental to our health. Most food we eat has some amount of fat in it. Sometimes it is very visible, such as in oil or in batter or in the marbling of meat. Oftentimes, you cannot see it, so you may not even be aware of it. Some of this fat is greasy, meaning it is partly melted and leaves a film on many things it touches. An easy way to make this fat visible is the so-called grease spot test, also known as the brown paper test. The brown bag or paper test is used to identify lipids easily due to the oily nature of the hydrocarbon chains. So, do you want to test for the presence of lipids? Then, what are you waiting for? Grab some of your desired substances and see yourself in this activity. In this experiment, we will be using brown paper, pencil, scissors, oil, water, 1/2 teaspoon bread, 1/2 teaspoon milk, 1/2 teaspoon flour, and 1/2 teaspoon peanut butter.
To start, cut the brown paper into small squares. You will need 1 square per substance tested. Write the name of the substance on its respective brown paper square. Make solutions of several substances you want to test for lipids. Mix 1/2 teaspoon of ground food with 1 teaspoon of water. Put a drop of food solution on its corresponding brown paper square. Take care not to cross-contaminate the substances tested. Spread the drop around by turning the paper side to side. After drying the paper, hold each paper up against the light and observe each spot. The foods that contain lipids will leave a greasy mark on the paper. The spots on the brown paper indicates that bread, peanut butter, and oil contains lipids. The same is true with milk, which has a little bit discoloration. That is nothing unusual since there are some fats that are in milk. Conversely, flour and water do not have any discoloration. This indicates the absence of lipids.
What do grease marks tell us? Did you see some really big grease spots on the brown papers? This is no surprise. Fat is after all the major ingredient of many foods, as you probably noticed when you look at their nutrition labels. When you just look at foods, however, you do not necessarily see all the fats that they contain. Only when you leave them on brown paper for a few minutes do you start to detect these invisible fats as the paper becomes very shiny and slippery from all the grease. Why and how is it so? In trying to answer these questions, we shall look on the physical properties of fatty acids. Fatty acids are carboxylic acids, therefore, they are weak acids. For fatty acids, the value of pKa is around 4.5. Therefore, generally speaking, fatty acids are neutral below pH 4.5 and charged above pH 4.5. The carboxylic acid chains that comprise a fatty acid is made up of a nonpolar hydrophobic tail that is insoluble in water and a polar hydrophilic head that is soluble in water. These long nonpolar hydrocarbon tails of fatty acids are responsible for most of the fatty or oily characteristics of lipids. Fatty acids do not dissolve in water. Instead, they are dispersed by the formation of micelles in water. A micelle is formed when the tails become tangled, leaving the charged heads sticking out into the solution. Fatty acids are non-volatile, meaning they have a very high boiling point and do not evaporate easily. In contrast to water and flour used in this experiment, fats that get absorbed by paper cannot get enough heat to evaporate at room temperature, resulting to grease spots. This characteristic is again associated with fatty acid hydrocarbon chains. The oil has the longest hydrocarbon tails and thus the highest boiling point among the substances tested as it has the largest grease spot, while the milk has the shortest hydrocarbon tails and thus the lowest boiling point because it has the smallest grease spot. Unsaturated fatty acids have lower boiling points than saturated fatty acids. The reason for this phenomenon can be found by a careful consideration of molecular geometries. The tetrahedral band angles on carbon results in a molecular geometry for saturated fatty acids that is relatively linear. On the other hand, the introduction of one or more double bands in the hydrocarbon chain in unsaturated fatty acids results in one or more kinks in the molecule. These kinks cause its structure to not stack properly, resulting to weaker intermolecular interactions. Consequently, less energy is required to separate the molecules. Thus, they have lower boiling points. Therefore, in this experiment, the oil, bread, and peanut butter all have saturated fatty acids, resulting to larger grease marks after a short amount of time, while the milk has unsaturated fatty acids, resulting to small grease marks after a short amount of time. Meanwhile, water and flour do not contain any fats at all, as they did not leave any grease marks on the paper. Why does grease make paper translucent? To understand why, we need to understand how light interacts with matter. The colors we see are the different energies of visible light waves. We see these waves as the different colors of the rainbow: red, orange, yellow, green, blue, and purple. The color of the object that we see is the color of the light that is reflected. A banana is yellow because yellow light is reflected back to our eyes and other wavelengths of light are absorbed. The same thing happens when light hits a piece of paper. Paper is made of fibers, and there are little pockets of air between those fibers. When fat is absorbed into the paper's pores, the grease-stained part of the paper, which is normally white due to the scattering of light that shines through it, allows less scattering, and the light passes through it, appearing darker in color and translucent.